On October 11, 1965, the eve of Columbus Day, one of the world's most respected universities revealed a document that appeared to rewrite the history of the Americas. It was not a ship, not a skeleton, not a ruin buried under soil. It was a sheet of parchment, roughly 11 by 16 inches, thin, fragile, made from sheepskin, and drawn across its surface was a world that should not have existed. In the upper left corner, beyond Europe, beyond Africa, sat a large island labeled Vinland Insula, Vinland. If the map was genuine, it meant that America had been drawn centuries before Columbus ever sailed. Within days, newspapers around the world called it one of the most important historical discoveries ever made. Within decades, science would prove it was almost certainly a forgery. This is the story of the Vinland Map, one of the most famous contested artifacts in modern scholarship, and how chemistry, physics, and forensic analysis dismantled a historical bombshell, molecule by molecule. The story begins in 1957. A London rare book dealer named Lawrence Whitten acquired a strange medieval volume. Inside it was a map, bound alongside a manuscript known as the Historia Tartarorum, a 13th century account of Mongol expansion. Whitten eventually sold the material to a private benefactor, who donated it to Yale University. When Yale unveiled the map publicly in 1965, the academic reaction was electric. By that point, archaeologists already had strong evidence that Norse explorers had reached North America around the year 1000, most notably the settlement at L'Anse aux Meadows in Newfoundland. But a map changed the stakes. A map meant geographic knowledge. It suggested that medieval Europeans, or Norse navigators, had not only reached the New World, but documented it. The parchment itself appeared medieval. The handwriting looked period consistent, and the geography, at first glance, seemed plausible, until experts started looking closer. To a casual observer, the Vinland map looked ancient. To a trained cartographer, it looked slightly wrong. The most debated feature was Greenland. On the map, Greenland appears as a distinct island with a surprisingly complete outline. In the mid-15th century, the approximate date suggested by the parchment, European geographic knowledge of Greenland was fragmentary and incomplete. No reliable medieval record demonstrates a confirmed, full circumnavigation producing such a coherent island depiction. It was not impossible in principle, but it was historically suspicious. Other anomalies appeared. The ink tone was unusual. The lettering showed fewer natural variations than typical medieval hands. Nothing individually proved fraud. Together, they raised doubt. Science stepped in. In 1972, Yale permitted detailed chemical analysis led by microanalyst Walter McCrone. McCrone examined microscopic samples of the ink, particles smaller than a grain of dust, using advanced optical and electron microscopy. What he found changed the debate permanently. The ink appeared layered. A darker, carbon-rich component sat above a yellow-brown line designed to mimic the aged appearance of traditional iron gall ink. When McCrone analyzed that yellow component, he identified significant amounts of anatase, a crystalline form of titanium dioxide. Titanium exists naturally in the Earth's crust, but refined anatase pigment, in the form detected, became widely available only with modern industrial production in the early 20th century. A genuine 15th century map would almost certainly have used iron gall ink, a mixture of tannins from oak galls and iron salts that darkens and oxidizes over centuries. Iron gall ink contains iron. The Vinland map's ink did not behave like iron gall ink. This was the first strong chemical indication of a modern origin. Despite the chemical evidence, the debate did not end. Supporters of authenticity proposed alternative explanations. Perhaps the anatase was contamination. Perhaps medieval ink production involved unknown processes. Then, in 2002, radiocarbon dating confirmed something unexpected. The parchment itself dated to approximately the mid-15th century. The material was genuinely old. Now there was a paradox. 15th century parchment, 20th century chemistry. The most straightforward explanation was also the most uncomfortable. Someone had drawn a modern map on authentic medieval parchment. In 2021, Yale initiated a comprehensive re-examination using modern, non-destructive analytical methods. Among them was X-ray fluorescence spectroscopy, or XRF. XRF works by bombarding a material with high-energy X-rays. Atoms within the material emit characteristic energy signatures, effectively a chemical fingerprint. Researchers scanned the entire map. Titanium was not present in isolated contamination. It appeared consistently across every ink line. Equally important was the comparison with the manuscript bound alongside the map. The authentic Historia Tartarorum text contained classic iron gall ink, rich in iron, sulfur, and copper. The Vinland Map ink contained almost no iron. It behaved chemically like a titanium-based pigment. Then, investigators identified a critical detail. On the reverse side of the parchment was a faint Latin annotation, likely from the original medieval bookbinding process. Analysis showed that this note used genuine medieval ink matching the manuscript. The map drawing did not. A medieval page had been reused. The map was added later. The conclusion was decisive. The Vinland Map is a modern forgery executed on authentic 15th century parchment. At first glance, this might seem like an obscure academic dispute, a fake map, a solved mystery. But the deeper lesson is more interesting. The underlying historical claim that Norse explorers reached North America is true. Archaeology confirms it. The forgery exploited a real historical narrative. It attempted to provide the one thing historians did not yet have: a contemporary visual record. The map succeeded because it told a story people were already prepared to believe. Science did not reject the story. Science tested the artifact. Carbon dating, microscopy, spectroscopy. Each method read the physical evidence directly. Ink chemistry does not respond to reputation. Atoms do not care about historical prestige. Today, the Vinland Map remains in Yale's collections, but its status has changed. It is no longer displayed as a revolutionary discovery. It is studied as a case study in forgery detection. A reminder that authentic materials can be used to produce convincing false histories. The artifact tells us little about the 15th century. It tells us a great deal about the 20th. It demonstrates that a single trace element, titanium, can overturn decades of scholarly debate. For nearly 60 years, the Vinland Map existed in a strange space between possibility and proof. A beautiful object, a compelling narrative, and a growing list of inconsistencies. When the final analyses were complete, the mystery did not vanish. It transformed. The real discovery was not a lost Viking chart. It was a demonstration of how modern science can reconstruct truth from microscopic evidence. History is not built on belief. It is built on what the physical record can sustain. And sometimes, the difference between legend and fact is measured in molecules. If you value evidence over legend and proof over assumption, stay with us. There are still truths the record has not fully revealed. Veil origins. Impossible truths.